Once again, hello math scholars. We're here for a lesson 47. Got my smiley sunshine face because right now the sun is shining, but it's starting to rain every once in a while. And again, as usual, please make sure that you add lesson 47 to your table of contents, which is about the powers of 10. Powers of 10 would be the topic, and we are on page 130. Page 130 in your notebook, lesson 10, lesson 47, powers of 10. Powers of 10 sounds a little ominous, but it's really not hard. You'll remember that decimals are deci, which is 10, so we're talking about tens, and our whole number system with decimals and all is based on powers of 10, so it really won't be that difficult. I think you'll catch on right away. Okay, so the positive powers of 10 are positive powers of 10. If we have 10, this is the same as 10 times 1. Then if we have 10 times 10, we're looking at 10 squared, which is 100. If we have 10 times 10 times 10, we're looking at 10 3 times, or 10 cubed, which is a 1 and 3 zeros. 10 times 10 times 10 times 10, which would be how many tens? 4 tens, so 10 to the 4th, or a 1 and 4 zeros. And at this point then we can put some commas in here. So I think maybe you can see the pattern. 10 right here with a little 1 is just 10. And 10 twice is 2 tens. 10 3 times, or to the third, is 1,000. And 10 4 times, or 10 to the 4th, multiplying 10 times 10 times 10 times 10, is 10, or 1 with 4 zeros. So 10,000. We're looking right here at exponents. If I have 10 to the 3rd, this number right here, I think we've learned in previous lessons, is called a base, and this number is called the exponent, or power. Exponent or power. It shows how many times the base is to be multiplied by itself. It shows how many times the base is to be used as a factor. So taking away from tens, this is important because we're just seeing that it just adds zeros onto it. What if I had 2? 2 to the 1 is 2 times itself just once. 2 times 1, or just 2. 2 squared is going to be 2 times 2, or 4. 2 to the 3rd is 2 times 2, using it 3 times, and we learned that 2 to 2 is 8, and so on. So when the base is another number, again, it's multiplying by itself that many times, and we'll come up with different. When the base is 10, then we're simply just adding zeros as we go. All right. If I take 10 to the 3rd and I multiply it by 10 to the 3rd, what will I get? I'm going to get 10, 10, 10. There's our first 10 to the 3rd. And I'm multiplying by 10, 10, 10. How many tens are there? 10 to the 6th. Now think about that. What's happened between the 3 and the 3 as we multiply 10 to the 3rd times 10 to the 3rd? That simply is adding. Well, does it really work? Let's try 2 to the 3rd times 2 to the 2nd. What would that be? Well, 2 to the 3rd is 2 2, 2 times 2, 2. 2 times 2 times 2 times 2 times 2 comes out to be 2 to the 5th. Well, does that hold true, that 3 plus 2 is 5? Yes, and so we can make the assumption that when we're multiplying numbers with powers, and as long as the base number is the same, then our exponents simply are added together. Well, that's multiplication. Wonder if it works for division. What do you think? Let's find out. Let's take 10 to the 6th and divide it by 10 to the 3rd and see what we get. Division, well, that's like a fraction. So if I have 10, 10, 10, and so on, 1, 2, 3, 4, 5, 6, and I divide it by 10 to the 3rd, what actually is happening here? That created a 1, and 1 times anything, the identity property, and that created a 1, and that created a 1, so what do I have left? I have left 10 to the 3rd. Well, what happens between the 6 and the 3 to create the 10 to the 3rd? Up here it was addition, and here it is subtraction. Let's try again with some 2's. Let's try 2 to the 4th divided by 2 to the, let's take 2 to the 2nd and see what we get. Okay, that means we're going to have 4 2's, and we're going to divide by 2 2's. Again, notice that the base number is the same. This works while the base number is the same, at least for right now. This creates a 1, this creates a 1, and what do we have left? We have 2 squared left over. So we were able to do it with the 2's. We're just subtracting the exponents. So our rules of exponents, and I'm going to write it right here, and this is something you need to remember. Our rules of exponents in algebras states that a raised to any number multiplied by a, the same base, raised to any other number is going to be a x plus y, because where we're adding the exponents and the base remains the same. This also works if we have a to the x and we're dividing by a to the y. Our result will be a to the x minus y. And guess what? It even works when the bottom number is larger than the top number. We're going to find out how that will then give us a negative exponent. Right now we don't want you to worry with negative exponents, but it will happen. All right, so what if I did this? What if I do a to the x in parentheses and I put a y out here? What is that about? Well, what's actually happening here is a to the x times y. So this becomes ax y, and that may be a little bit different. Let's do one of those over here. Okay, I'm going to draw myself a dotted line, and let's try it with tens. What if I have 10 to the 3rd and I raise that to the square? That would mean that I have 10, 10, 10, and then I'm squaring this whole thing. In other words, multiplying this by itself. So that's another 10, 10, 10, which will give me 10 to the 6th. So what has happened here? Is it addition? No. In this case, it's what? It's multiplication. When there's parentheses like that, these two exponents are then multiplied. Okay, let's try another one to see if that works. Let's take 2 to the 5th and then raise that squared. So we have 2, 2, 2, 2, 2. That's 2 to the 5th. And we're going to square it, which means we're going to multiply it by that again. Well, what is 2 to the 5th? Well, there we have 8, 16, 32. And we're going to multiply that by 32. Oh my goodness, that's 4, 6, 6, 9. We have 4, 12. Is it really going to be 1024? Well, what happens when we do this? What's 5 times 2? 5 times 2 is 10. Oh my goodness. 2 to the 10th. I think I've messed up here. This is 8. 8 times 2 is 16, and 16 times 2 is, Okay, had to take a little pause there. You'll notice that I've changed something here. 10 to the 6th is actually a 1 and 6 zeros. And my mathematician right here is correct, 1024. And 2 to the 10th, if you multiply that out, I had to do it on a scientific calculator, comes out to be 1024. This is not the same as with the tens, where we can just add a number of zeros. It doesn't work that way when your base is 2. This is called a base of 2. This is a base of 10. We can just add zeros. But when you have a base of 2, it comes out differently because, of course, our base is much smaller. But the principle is the same, that it's going to be 5 times 2 when we have the parentheses. So be careful with that. When there are no parentheses, you're just adding or subtracting the exponents. When there are parentheses around it and then it's raised again, you're multiplying. All right, moving on to the next sample. This is going to be page 131. And we're on lesson 47, continued. All right, let's see what we can do here. It says find the missing exponents for A. We have 2 to the 4th times 2 to the 2nd. So if we follow our principle, the base remains the same, and we simply do what to the exponents? That's correct. We're going to add them so that this would be 2 to the 6th. And that is correct. And again, to prove that, you have 2, 2, 2, 2. There's 2 to the 4th times 2 times 2. 2 more. So that's how many 2's? 6's. 6 2's. Yep. Letter B, 2 to the 4th divided by 2 to the 2nd, which I think we did already. This time we're going to do what to the exponents? We are going to subtract the exponents, which should give us 2 to the 2nd. And we proved that with 2, 2, 2, 2 divided by 2, 2. And what are we left with? 2 to the 2nd. Letter C, we have 2 to the 4th, and we're going to raise this to the 2nd. So that means we have 2 to the 4th, like we did earlier. And we're going to multiply by itself, so by 2 to the 4th again. And that would be 2, how many times? To the 8th, because 4 times 2 is 2 to the 8th. So that's how this works. And of course you could multiply 2, 2, 2. There's 8 times 2 is 16 times 16 and come up with your number there. All right, in the book, they talk to you about how we use powers of 10 to show place value, and I'm just going to slide the book right under here, and we'll zoom into this just a tiny bit, the part that I want you to see, if I can get it to zoom a little bit more. And now please focus. Okay, we can use powers of 10 to show place value, and what they want you specifically to see, and why I highlighted it in yellow, is that 10 to the 0 is simply just 1. The exponent tells us how many zeros are added to the 1. So a 10 to the 0 would be the number 1. A 10 with a 1 raised to the 1 tells us that there's 1 0. It's a 1 and 1 0. 10 squared is a 1 and 2 zeros. We're out in the hundreds place. And so on. 10 to the third, we're now in the thousands, 10,000s, 100,000s, and it just keeps getting bigger and bigger. But the important one to note here is that 10 to the 0 is simply a 1 with no zeros added on, so just 1. And 10 to the 1 is a 1 with 1 0 added on, so that's 10. 10 to the 2, a 1 with 2 zeros, or 100. Powers of 10 are sometimes used to write numbers in expanded notation. And where our lesson is taking us now is going to be writing in expanded notation in powers of 10. So I will refer you to the chart. Let me back out a little bit here. I'm going to refer you to the chart on page 337 for some more information there. And what they're asking us to do now is to write 5,206 in expanded notation. Okay, so let's think about this. First thing we have to do is break these down into their values. What place are they in? Well, this 5 is in the thousandths place. The 2 is in the hundreds place. There is nothing in the tens place. And we have a 6 in the ones place. So the 5 represents 5,000. We're going to write 5 times 10 to the, if you look at your chart, what's the thousands place? 10 to the third. And another easy way to do that is go 1, 2, 3 places out. So 10 to the third. We're going to add that to our 2, which is in the hundreds place, so times 10. How do we make 200? 10 squared, the hundreds place, so that would be 10 times, or 2 times 100. This would be 5 times 1,000. We don't have anything in the tens place, so we're going to leave that completely alone. And our 6, we don't just write 6 times 1, we're wanting to know what power of 10. So it's 10 to the 0, because 10 to the 0, as you'll remember, is 1. So 6 times 1 is 6. So this is writing the number 5,206 in expanded notation. You only need to expand those that are actually holding place value. And since the 0 does not hold a value, we don't have to do that. All right, now moving into decimals. When we multiply a decimal number by a power of 10, here's where it gets fun. We simply move the decimal point. If I have 46 and 235 thousandths, okay, this is a nice number with thousandths places. If I multiply that by 10 to the second as the sample in your book, I am actually multiplying by 100, and multiplication makes the number larger. So making the number larger by 100 is the same as moving the decimal point 2 places to make the number larger. We're multiplying, we're making it bigger by 2 decimal places. So which way would the decimal point move to make it bigger? That's right, 46 make it bigger, we move it 10 place, move it 100. So multiplying this by 10 to the second moves the decimal point 2 places. 46, move 2 more places, and then replace that decimal point. So our answer is right here. Get your commas in there. 46 and 235 thousandths times 10 to the second is 4,623.5. We've moved the decimal point 2 places. That's when we're multiplying. Okay, just a shift of the decimal place. Let's talk about division. What if I have 3.5 or 3 5/10, and I'm going to divide by 10 to the fourth? Well, earlier we saw that when we are multiplying exponential numbers with the same base, we simply add the exponent. And when we're dividing exponential numbers with the same base, we subtract the decimal point. Do you suppose that if we move the decimal point when we're multiplying by a power of 10, when we're multiplying, that when we're dividing, we actually move it the other way? Doesn't division make a number smaller? So if we're dividing by 10 to the fourth, your guess is right. You're going to move that decimal point to the left 4 places. So here's 1, 2, 3, 4. And you're telling me, but there's no numbers there? That's because we now have to fill in those numbers. And please don't forget the place value number at the beginning. So 3.5 divided by 10 to the fourth will make our number smaller by like 10,000 places. So it's going to be 0.1, 2, 3, and then 3, 5. The decimal point is no longer there. It's up here. We have moved it 1, 2, 3, 4 places. Now look, 3.5. If I move this 4 decimal places, I'm right there. I still have my 3 and my half. I'm hoping that this is making sense to you a little bit. Let's try another one. Let's try 12.5 and let's divide by 10 to the, I don't know, let's do 10 to the fifth. 12.5 divided by 10 to the fifth. If we're dividing, we're going to make this number larger or smaller? We're making the number smaller. And how many places are we going to move the decimal point? We're going to move it 5 places. So here's 2, 3, 4, 5, and now our decimal point is there, and be sure to put your place value holder there. So 1, 2, 3, 4, 5. So our answer is, we've made a really small number, 0.123125. Tenths, hundreds, thousandths, 10,000ths, 100,000ths, millions. 125 millionths. See how that works? 125 millionths if they were to ask us. But the point here is, if we're multiplying by an exponent power of 10, we're making the number larger by that many places. And if we're dividing by a base of 10, we make the number smaller by that many places. One more thing I want to show you before we branch off and let you go and do the actual assignment is that sometimes these numbers are written with words. If I have 1.5 and I've written that with the word million, actual million, 1.5 million, what would 1 million look like? 1 million, 1, 2, 3, 1, 2, 3, right? And then this 0.5 tells me 500,000, which is, what's half of 1 million? 500,000, yes? So 1.5 million gives us 1 and then 500,000. This is 1,500,000. And when we write it in words, it's the same thing. 1 million and then half of a million, 0.5. So 1.5 million is how we say that. 1.5 million. 1.5 million turns out to be 1 million and half of a million, or 1.5 million. So if I gave you 2.5 billion, remember you have 2 billion and then half of a billion, so you have 2 billion, and then half of a billion is going to be this 500, and then how many more zeros? Right? 2.5 billion, so 2 billion and 500 million. Let's write this in expanded notation. That's going to be 2.5, and then what does it take to get a billion? Times 10. How many places are we moving that? 1, 2, 3, 4, 5, 6, 7, 8, 9 to get it right here. So that would be 10 to the 9th. 10 to the 9th. So 2.5 billion would come out looking like that, and is actually 2.5. And then you can look at that chart if you want, or you can count up how many zeros would be behind it. To get to the billions place, you have 9 place values with 0, and here's your decimal point. All right, I hope that works for you. And if you have any questions, you be sure to ask. So there is lesson 47.